after the collision, right? And then we will use what? Energy. But in this case, they move as an assembly.
Yes.
It's the same than the ballistic pendulum we solve here. It's pretty much the same idea of the ballistic pendulum we solve here. So those 4 problems I said are related to the ballistic pendulum. Right? So a question like that where I combine energy and momentum will be a possible free response question in the test. So a question where I combine energy is a possible question. So I said that now in this test will be 2 questions in the test. Free response. 2 questions. One is a question where I will give a certain setup and you have to apply the first conservation law, W net equals delta K. You have to use the second or you have to use the third, which I taught how to choose or make the selection of one of the 3 laws. In the study guide, you have many problems that could be a free response in the previous study guide. So one of those 3 situations I can give a block, a spring, anything like that, and I can ask, find the velocity after, final. Find the work done by the friction. Find it. This will be the first questions in your free response, which I will go more in detail with pictures and all this in the next class. The type of question, but definitely will be related to the application of the 3 conservation law we learned here. So how to use energy to find different things. The second free response will be related to a combination of momentum and energy, which is basically similar to the ballistic pendulum problem. Not necessarily the ballistic pendulum, but any type of question like this one that we have here, where you can apply momentum and energy together. These are the 2 free responses. Good. In the next topic, we will study elastic collision. We finish with inelastic. Elastic. Okay. So, elastic collision. So pretty much I will finish most of the topics today. So the next class will be just to answer your multiple choice questions if you have on the 2 study guide. Basically, I went over the whole first study guide. So it's just a particular question you can have there. And if you have question in the second study guide, which is this one, linear momentum. And I will just explain different perspectives of the free response questions. Different types, different perspectives. So basically it won't be a long class. Okay?
Professor, the momentum study guide is going to be on the next test? It's going to be on this test? So it's 3.
The first question is 2, right? But I'm talking about energy study guide, which is 2 study guide, right, in 1, and the linear momentum study guide. So there are, if you want to call 3, but I am just differentiating between energy and momentum. You understand what I mean? So 2 study guide.
So the study guide of momentum is going to be on this next test?
Yes. So linear momentum will be in the test. It's stated in the syllabus. So in the syllabus, I said exam 2, chapter 6 to 8. Normally this is 6 to 8 is energy, potential energy, and linear momentum. These are the 3 topics in this test, which is the second test. Yeah, I usually teach, and when I finish the topics, you have the test. So this is a normal, in every class, right? So you, most of the time, you teach, and what you teach will be in the test. And if there is a review also, can be a review. So everything under the plan, right? Energy, potential, work and energy, potential energy, and linear momentum, which will be finished today. And we have always time to go over the study guides in class, which I go over most of the problems, giving hints. And beside that, we have 1 day for review. So I think that is pretty good pace. So we have everything. Right? Okay. Elastic collision. I think that if I included this linear momentum in the other test, you will be crazy. Because the next test will be probably the most difficult because it's rotational motion and the gravitation. So if I include linear momentum, rotational motion, and gravitation, even will be worse. So the best thing is energy and linear momentum, which is similar topics, the topics that are interconnected. Okay. Elastic collision. In elastic collision, the momentum conserved, but also the kinetic energy, if it's in one dimension, will conserve. Example, which I showed you last week, instead of this, which there is a change in the original structure of the object,